Hello viewers, welcome to JSM. In this lecture, I am going to explain one very important topic, that is Coulomb's law. This is very important in the electrostatics. So here, what is the use of Coulomb's law? So it explains about how an electric charge interact with another electric charge. Okay, see, we know this one very fundamental concept already we discussed in the introduction lecture. See, if we have like charges, they repel each other. If we have unlike charges, they attract each other. Now the question is that how much is the repulsive force between them, or how much is the attractive force between them. So to calculate that, this Coulomb's law is very useful. Okay, to calculate the repulsive force or attractive force between the two charged bodies, is this Coulomb's law is useful. Okay, and one more thing, see, this Coulomb law is generally by considering point charges. Okay, Coulomb's law, he consider generally point charges only. Okay, what is a point charge? Suppose here we have two charged bodies. Okay, two charged bodies separated by some distance. Now if the size of this charged body is very small in comparison with distance between those two. Okay, once again I am repeating, if a charged body is considered to be a point charge, means so the size of charged body must be very small when compared to the distance of separation between those two charged bodies. Okay, one more thing here, don't think that this point charge means that is a very small charged body, not like that. Suppose if we consider a football size charged bodies we have. Okay, we know that football is somewhat larger when compared to the small sized particle. Okay, so now if those two bodies are close to each other like that, they are not considered as point charges. But if those two bodies are separated by a large distance, 100 meters or 200 meters for example, like that, in that case now the size of this football is also very small when compared to the distance between them. Okay, so that's why they are considered as point charges. Clear? So now here let us consider, we have two charged bodies. First one, its charge is q1, and we have another charged body, that is its charge is q2. Okay, so we have two charged bodies q1 and q2. I am considering here both are same charge. Okay, positively charged. And now so these two charged bodies are separated by a distance of r. Okay, so these two are separated by a distance r. Now see, both are positively charged bodies, means they repel each other, right? They repel each other. Now here, so this q1 is repelled by q2 like this in this direction, and see here this q2 is repelled by q1 in this direction with some force. Okay, so it is repelled by q2 with some force. q2 is also repelled by q1 with some force in this direction. Okay, so here now this force is, we can write it as F12. Okay, so here force on first charge due to second charge. Okay, force on first charge due to second charge, F12. Okay, and here this we can write F21 bar. Okay, so this is force on second charge due to first charge. Okay, force on first charge due to second charge, and this is force on second charge due to the first charge. Okay, and one very important thing here is that, okay, and one very important thing here is that, see here the force. Okay, the force always acts along the line joining, two charged bodies, okay, so this force which is acting on first one due to 2, or the force on 2 due to 1, they always act along the line joining those two charged bodies. The force will never act like this. Okay, in this type of directions, not possible. Here also only along in this direction. Okay, clear? That is a very important thing here. Remember this, force always act along the line joining two charged bodies like this. They may be positively charged or negatively charged or positive and negative charge, whatever it may be. That may be attractive force or repulsive force, whatever it may be. Same thing here. Okay, clear? Very, very important. And now another thing here is that, see, this F12 and F21 both have equal magnitude but opposite direction. So, force on first charge due to 2 and force on second charge due to 1 both have equal magnitude but opposite direction. Very, very important. Okay, both have equal magnitude, only direction is opposite. Clear? Okay, so now here how we can calculate the force. Okay, so here the force is directly proportional to the product of two charges. Okay, so F is directly proportional to the product of two charges, and also that is inversely proportional to the square of the distance between those two charged bodies. Okay, clear? F directly proportional to Q1 into Q2 and F is inversely proportional to the square of the separation distance between the charged bodies which we are discussing. Okay, so therefore here we can write that F is proportional to Q1 by Q2 upon R square. Okay, Q1 Q2 by R square. Okay, so if we remove this proportionality, we get a constant, that is F is equal to K into Q1 Q2 by R square. So by using this relation, we can calculate the force. Okay, see from this, if those two have high charge, then force is also more. Yes or no? And if the distance is small, force is more. Distance is very large, then the force is less. Okay, so this is the proportionality constant. Okay, and one more thing here, this K depends on the medium in which we are doing these calculations, or in the medium in which these two charged bodies are present. Okay, so that is a very, very important thing here. So now let us see these two expressions just now we discussed. See now magnitude of electric force exerted by Q2 on Q1 or Q1 on Q2, let us assume it as F. Okay, so this is the magnitude of electric force. So that is equal to mod F12 bar, that is equal to mod F21 bar. So that is equal to K into mod Q1 Q2 upon R square. Okay, so this is the expression for the magnitude of electric force. Remember that. Okay, so that is the reason why here we are taking modulus. Okay, clear? And now here, what is this F12 bar and F21 bar? So F12 bar, that is equal to K Q1 Q2 upon R square. What is this? Force on Q1 due to Q2, right? So F21 bar, what is this? K Q1 Q2 upon R square. This one, force on Q2 due to Q1, right? So already we discussed. This is the expression. Now see here. So we are using same relation, right? But here, so depending upon the charges which we are taking, both may be positive, both may be negative, or one is positive and one is negative, whatever it may be. See here, while writing this one, okay, so while using this, we must substitute Q1 and Q2 along with their charge. See here, all we have a modulus, so only magnitude we are considering here, that's why we took modulus here. But here in this expression, you must substitute both the charges along with their sign. So by that only we can identify whether the force is attractive force or repulsive force. Suppose these two are same charged, Q1 and Q2. Both are positive, plus into plus, plus only. Both are negatively charged, minus into minus, plus only. Means if the force is, okay, force is positive, then that is repulsive force. Okay, if the force is negative, then that is the attractive force, right? If both are negatively charged, then the force is attractive force and the value will be negative value. That is nothing but the attractive force. Okay, so here, see one more thing. Suppose here we have Q1, here we have Q2. Okay, both are separated by some distance. Now here, if both are same charged, both are positive or negative, what is the force? That is repulsive force is present here, right? If suppose both one is positively charged and one is negatively charged, then there is a attractive force, right? Then there is a attractive force is present. See what, but whatever it may be, repulsive or attractive, see both are in the opposite direction. See, this is like this, it is in this direction, opposite. Here also, see both are opposite. So whatever it may be the force, attractive or repulsive, remember that both are in opposite direction. Okay, clear? And how can we identify? Depending upon the sign. If force is positive valued, that is the repulsive force. If the force is negative valued, then that is the attractive force. Clear? Next, see, this is the equation which we use to calculate the force between the two charges. Okay, so from the Coulomb's law. Okay, how we can define the Coulomb's law now? The force of attraction or repulsion between the two charged bodies is directly proportional to the product of charges and also inversely proportional to the square of the distance between those two charged bodies. Okay, see here, what is this significance of this K? Proportionality constant. See, this K value, it is not fixed. K value depends on the medium in which we are doing this experiment or we are taking the charged bodies. Okay, so this K is equal to 1 by 4 pi epsilon naught. Okay, so here in free space we are discussing actually now. Okay, in the free space or air we are discussing what is this epsilon naught. This epsilon naught is permittivity of free space. Okay, permittivity of free space, and this K value is equal to 9 into 10 power 9 Newton meter square per Coulomb square. Okay, so why, how we are getting that? See, from this expression we can rearrange this. K is equal to F into R square by Q1 into Q2. For force, what is the unit? Newton. For this meter square, so here two charges, Coulomb into Coulomb square. So like this we are getting Newton meter square per Coulomb square. Okay, and also this epsilon naught value is equal to 8.854 into 10 power minus 12 Coulomb square Newton meter square. Okay, so this is the value of K, proportionality constant in free space, remember that, and this is the permittivity of free space. Okay, clear? So this is how we can use Coulomb's law to calculate the magnitude of force or force between the two charges, that may be attractive force or repulsive force. Okay, so in the next lecture we discuss important points in the Coulomb's law and also vector form of Coulomb's law. Thank you for watching.